Before the civilization of mankind took hold on this earth, amidst the tumbling waves of the early formation of this planet, life began with a single cell. Many believe that the cyanobacteria are the artisans of life on this planet, and that they created the atmosphere in which we breathe our oxygen. But in today's climate, are they proliferating at a dangerous rate? With this proliferation can come many risks, but today I would like to focus on one of these specific risks: the cyanotoxins. These cyanotoxins are known to be present in the southeastern United States, and that is what I am going to present to you guys about today. My name is Seth McWhorter, and I am a student at UGA, a PhD student, under Susan Wild and Gary Green. But let's get on into it. So, as I said, cyanobacteria can have negative impacts on places that they are present in. They can become harmful algal blooms, or CHABs. They're harmful, or they become prevalent due to eutrophication, which is increased nutrient content, such as higher nitrogen as well as higher phosphorus. This eutrophication can be from agricultural resources, such as farming runoff, fertilizer runoff, and it can also be due to higher productivity from higher temperatures due to climate change. As we see increasing temperatures and increased pollution, these places, these freshwater systems can become impacted by CHABs, and they can become ubiquitous in a system. They're common in marine environments, but as well as freshwater, and today I want to focus on the freshwater habitat and how CHABs impact them. What are some of these negative impacts that we're talking about of CHABs? Well, as they proliferate in the system, they're going to be most of the time in the upper layer of a lake, and they're going to block out some sunlight and decrease light availability to lower submerged aquatic vegetation. They're also going to uptake CO2 at a higher rate and decrease free CO2. This decrease in free CO2 is going to result in higher hydroxide ions in the water, leaving the pH higher than it should be. This is all very bad for things living inside of the water, and these changes can cause deaths in submerged aquatic vegetation, which can lead to anoxic conditions, lack of oxygen. That lack of oxygen can result in the death of other higher trophic level organisms such as fish. Now, all these are really bad, obviously, but I want to focus on something that's even a little bit more concerning in my opinion, and that's their ability to release cyanotoxins into the water. Now, the threat of cyanotoxins ranges across trophic levels. And this is due to, they do not biomagnify, meaning cyanotoxin levels do not get higher up the food chain, such as mercury. However, they can still be transferred through consumption of organisms that have come into contact with cyanotoxins. And besides, all of these are impacted just by living inside the water of cyanotoxins. Now, cyanotoxins are expected to increase with climate change and as pollution issues are not being resolved. And we've seen that multiple species can release multiple cyanotoxins at the same time, and even single species can release multiple cyanotoxins. And these cyanotoxins, as I said, can have an impact across trophic levels, starting with our little friend here, the Daphnia. As Daphnia, say hello friend, as Daphnia consumes cyanobacteria that have cyanotoxins in their cells, they can have lower fertility rates and also begin to die. But not only can exposure to cyanotoxins harm our little Daphnia friends, there's also been cases of waterfowl that have been seen mass casualty events due to cyanotoxins, and even fish kill-offs from cyanotoxins. More so than just aquatic animals, we've seen cattle and other livestock die from consuming or drinking water that is contaminated. Even some of our pet dogs that have swam in water with cyanobacteria have ended up dying, especially from a cyanotoxin known as anatoxin A. And that's not all, folks. We also see that humans are impacted by cyanotoxins. There was a specifically horrific case in Brazil where dialysis patients received contaminated water intravenously. This resulted in quite a few dead patients. Now, this is an exception. This doesn't happen often. But we can still be exposed to cyanotoxins through aquatic recreational activities such as kayaking, canoeing, swimming, or fishing. But what I really want to talk about today is occurrences in the southeast. Now, my master's was focused on the Midwest, but CHABs are going to impact all of the U.S. And I'm trying to move what I learned on with my master's to the southeast for my PhD. And what we see is, while there are other areas that are going to increase, as you see here on this map, that are going to increase in cyanobacteria cell concentrations more severely expected to, we're going to see a lot of economic losses in the southeast. And this paper where I pulled this figure from says that the southeast is going to be hit hardest from economic losses with CHABs. And that could be potentially because of man-made reservoirs here, where we go to recreate. You see, man-made reservoirs a lot of times have pretty thick algal blooms compared to natural systems, and we don't take care of them as well as we might a natural system. Also, agriculture is very important in the southeast, and we seemingly don't put riparian buffers between our aquatic resources and these farms as much as we should. And that's going to lead to agricultural runoff that's going to flow into these reservoirs and create algal blooms. This is going to impact the fishing industry, as I said before. And there's a large fishing industry in the southeast, and we could see that impacted by CHABs in the near future. Some common cyanotoxins in the southeast include microcystin, cylindrospermopsin, anatoxin A, saxitoxin, and I focused on in my master's microcystin, saxitoxin, anatoxin A, and those three do occur in the southeast as well. But another one that I want to talk about that's actually kind of novel in the southeast is atoctinotoxin. This cyanobacteria is actually not associated with harmful algal blooms, as far as we know yet. What we've seen, though, is that cyanobacteria that grow on the underside of invasive hydrilla leaves can produce atoctinotoxin. This toxin was discovered by my advisor, Susan Wild, in the southeast, and it's been associated with bald eagle deaths. There's still a lot to learn about atoctinotoxin, but this novel toxin is not well understood yet, and also could pose a risk to humans. We don't know yet. But all of these toxins have been linked with being found in animal tissues. We've already found atoctinotoxin inside fish tissues, and we know that microcystin, saxitoxin, anatoxin A, and cylindrospermopsin are also found in fish tissues that are inside these CHABs. Say hello again, friend. To first put them through tandem mass spec, you have to extract them from the tissues. And I have created a methodology to do that I found successful for my master's program, and I want to use this methodology in my PhD to test animal tissues here. So, let's get into it. How does it work? Well, first, you weigh out fish tissue at a specific measurement, and then you add acidified methanol. After the acidified methanol is added, you homogenize with a homogenizer, and then rinse between samples. And then, after homogenization, you sonicate for 30 minutes. and store for 24 hours. After storing, I centrifuged my samples at 2000 rounds per minute for 10 minutes, after which I pipetted off the supernatant. And once that was pipetted off, I then added imheptane to the sample and shook the sample up. Shake that sample, Seth. Shake it. Then we recentrifuge, which I don't show here, and pipetted off the lipid layer. So that heptane is removing lipids from the sample to clean up the sample so it's easier to isolate compounds. Then I evaporated the solvent using nitrogen evaporation. And finally, when there was a little bit of solvent left, I evaporated using a centrivab. So as I said, I want what a beautiful picture that is of me, but I really want to take that to the southeast instead of just working on the Midwest, because there's not as much studies in the southeast on CHABs, yet these CHABs are going to impact the southeast in the very near future. So what's next for me in studying CHABs? Well, I want to continue testing water samples, especially in the southeast. And while we're testing water samples, I want to look at some hydrilla. We are looking at some hydrilla samples in Susan Wild's lab to determine toxicity. And as we continue looking at these, we're also going to look at some animal tissues and see if there's cyanotoxins in them as well, and some fish that we catch in active blooms. Finally, this is specifically for atoxin. We really want to look at some mammal studies for atoxin to determine the threat to humans. The threat to humans, because we have no idea what that threat is right now. Humans could be susceptible to atoxin, and right now we have no data to back that up. And hydrilla is very common in reservoirs. It's spreading like fire through reservoirs right now. And furthermore, I want to, with my PhD, create some community outreach programs so that we can increase public knowledge, because this is a real issue that people don't really know about, and people don't trust knowledge that's given to them, and we really want to bridge that gap between science and the community and help warn them that this is real and they need to watch out for their own health, for their kids' health, and also for their pets' health. And I hope that you've learned something from my presentation today. I know it wasn't very specific, but it's something that I'm passionate about, and I hope I can share that passion with you guys at UOM, because I really want to start working in this watershed some more and looking for these things. Anyway, here's Ocean Man.
Ocean Man, take me by the hand, lead me to the land that you understand. Ocean Man, the voyage to the corner of the globe is a real trip. Ocean Man, the rust of a tan man, and bite by the sand, soaking up the thirst of the land. Ocean Man, can you see through the wonder of amazement at the overland? Ocean Man, the crust is elusive when it casts forth to the childlike man. Ocean Man, the sequence of a life form raised in the sand, soaking up the thirst of the land. Ocean Man, Ocean Man, Ocean Man, take me by the hand, lead me to the land that you understand. Ocean Man, the voyage to the corner of the globe is a real trip. Ocean Man, across the stub of tan man and bite by the sand, soaking up the thirst of the land. Ocean Man, can you see through the wonder of amazement at the overland? Ocean Man, the crust is elusive when it passes forth to the childlike man. ocean man, the sequence of a lifetime racing the sand, soaking up the thirst of the land. Ocean man.